Afternoon. Is the sound working on my side? Hmm. I hear some things, but not everything. Is that working? Hmm.
I can hear Benjamin, but nobody else.
I wasn't
I can hear you, but nobody else.
I can put my
Oh,
mic on, and then we have feedback.
yes.
So this is just the call. No?
Moi que le son.
Maybe you can just like...
Oops.
We kicked everybody out.
You hear us now?
Here.
Hear me, I
Back.
guess.
Yes.
Trying to get the room back in.
So we have a room apparatus that we want to be the one collecting the sound. So this is what is missing just now.
Yep. I think we're also having some people having trouble joining. At least one person has sent me an email that they're unable to get in. They're waiting for Matthew to let them in.
Cette réunion est en cours d'enregistrement.
We have the room sound now? Yes, we have the room sound, right? You can hear us.
Can you?
No.
Can you hear us?
I hear Mathieu Suzu, but I'm not sure I have the room.
Oh, that's fine then. If you have Mathieu Solo, you probably have everyone.
No, Mathieu.
No, you should have the Inria
The
Paris.
room is not there.
Oh,
I see it.
Yeah.
I see it.
so you can hear us at least.
And you can hear us.
I think so.
Good news.
Okay, so I think we can start,
Oh yeah, good.
right?
You see the room?
Yeah, I see the room, and I see that we're not using Mathieu's
Sound?
microphone.
No. Great. Great.
Can you hear us, Benjamin?
Yes, I hear you.
Very well.
Nick is still having trouble joining. Can someone put the link again in the chat and I can send it to him?
Yeah. Where did I put it?
Thank you.
Harry, Nicolas. Unable to join. I will put it again. Cook.
Il me dit, Mathieu me dit, il faut que tu me laisses entrer. Il me dit que merci d'avoir patienté, nous démarrerons la réunion.
Are you in the lobby, maybe?
C'est bon le lien là?
Il faut que tu recharges la page.
Oui, je l'ai ici, mais ça me bougeait, ça me dit que c'est pas test réunion. Je peux comprendre pourquoi je vais dans test réunion.
Yeah, you got it.
Oops.
Peut-être que.
I have another one.
I see.
Why do you have
I see
another
two
one?
different links there. Is the first one wrong?
No, the first one is the right one. 585.
Okay.
Yeah, sorry, that's
585.
that's mine. Yeah.
Je sais pas pourquoi la première fois ça m'a besoin
I see people joining.
Why do? So confused now.
All right, I think we're getting there.
No, these are two different links.
I'm connected for now. Should we use our laptop microphone? I guess better now when we are talking.
Okay.
It works this
No.
Great.
You cannot use your laptop microphone.
No, because we have feedback.
It's going to have a feedback.
Well, we are, Maxime?
Maxime, he texted me that he's 10 minutes late.
Okay.
We have 12 minutes late. Yes, he's arriving.
We can wait for him then.
I don't know.
We can go, it's recorded.
Maybe we can do, you need to do a round table while Maxine arrives. I think everybody knows Maxine. Almost everybody.
Yes.
Well, he can be the last to introduce himself.
On a rencontré
Okay, Benjamin, you want to start the round table?
Yeah. So welcome everyone, and thank you so much to the all the working group participants and developers for making space in your tightly packed program for a discussion about user interfaces. I think this is going to be a nice point of contact between lots of different communities that are interested in similar topics. I think maybe we should begin with a very quick round of introductions. Does that make sense? It's a lot of people, and at least the ones in the INRIA room are going to be hard for other people to see. But yeah, maybe just a quick round of names and affiliations. Does everyone have a stable order on their screen, though? Let's give it a try. All right. My name is Benjamin Pierce. I'm a professor at University of Pennsylvania. Julien?
Oh, I'm working with Yves Berthaud, and I'm also a Debian developer, packaging many Coq things for Debian.
Great, thank you. Mathieu?
Mathieu Sozo, I'm a Coq developer at INRIA.
Thank you. Yves?
I am a long-time Coq developer, Coq user, and a long-time ago Coq developer.
Shodul?
Hi, I'm a first-year grad student at EPFL, working with Clément.
Andrew?
Hello everyone, I'm Andrew Head. I'm a professor at Penn in human-computer interaction.
Clément, and then Harry?
Hi, I'm a first year professor at EPFL working with Shardul. I also maintain a few Coq packages here and there.
Harry.
Hi, I'm Harry. I'm a PhD candidate at the University of Pennsylvania.
Jesper.
Hello, I'm Jesper Beng.
Oh, sorry.
Oh,
I
no.
heard.
Sorry, Jesper and then Jessica.
Okay, my name is Jesper Bengtsen. I'm an associate professor at the IT University of Copenhagen.
Jessica.
Sorry. Hi, I'm Jessica. I'm a PhD student at the University of Pennsylvania.
Nick.
Hello, I'm Nick Baer. I'm a CNRS researcher at Université Paris-Cité at IRIF.
Simon.
I'm Simon. I'm a master's student at the IT University of Copenhagen, working with Jesper as supervisor.
Ali.
Ali. Hi, I'm Ali. I'm a student at the University of Gothenburg. I work on Coq sometimes.
Emilio.
Hi, I'm Emilio Gallego, and I work at the INRIA Paris in the PQ team. Raise your hand.
And let's see, Guillaume.
Hi, I'm an INRIA researcher, and I'm a Coq developer, and I'm also a maintainer of several Coq packages.
Great. And Romain.
Hey, hi, I'm an engineer at INRIA Sophia Antipolis, and I've been working with Maxime Denes and Enrico on DS Coq 2, and bringing it up to speed.
All right, and then are there others in the INRIA Paris room?
Yeah, sure. So, Kenji.
Kenji Maillard. I'm a researcher in Nantes. Mainly I'm a Coq user, and I'm trying to look at getting my hand at working on Coq itself.
Maxime.
I'm Maxime Denes. I'm a research engineer at INRIA Sophia Antipolis. I work mainly on DS Coq 2 these days.
Hugo.
Okay, Hugo Herbelin, so I guess you know me, old developer, I'm still developing a bit. And I just learned that there was this special session, but it's a very nice idea.
Enrico?
So hello, I'm Enrico Tassi. I'm an area researcher working in Nice with, well, these guys. And, well, I think for today I'm with Maxime and Romain on VS Coq 2.
Theo?
Hello, I'm Theo Zimmerman, now assistant professor at Telecom Paris, and doing documentation and contribution stuff in Coq.
Hello, Pierre-Marie Pedro, researcher at INRIA in Nantes, developing Coq.
Gaëtan.
Hello, I'm Gaëtan Gilbert, engineer at INRIA Nantes. I'm developing Coq.
And we've done the whole room here.
Yeah.
Mm-hmm.
Great. Well, this is exciting that this many people are interested in this topic. So let's dive in. So the way we're organizing this is we'll have several presentations, 1, 2, 3, 4, 5, 6, 7, I think. Short presentations, 5 to 10 minutes. I will try to lightly moderate so that none of them goes too long, but I think we should maybe try to be a little flexible and take time for questions in line, so it doesn't all get bunched up at the end. We have 1 hour and 40 minutes, so I think there should be plenty of time for these small presentations plus discussion at the end. So the way that I've organized it, and if anybody wants to suggest a reorganization, that's fine. But I thought maybe we should hear first from the Coq developer side. So how about Maxime, Roma, and Enrico first talking about VS Coq 2, and then Emilio talking about LSP, and then Yves talking about whatever he wants, and then others from the larger community, maybe beginning with Nick, and then Clément, and then Jessica, and then Jesper. Sound reasonable?
So I think I need a minute or two to set up the screen sharing. So Emilio, do you want to go ahead first?
I'm happy to start with
Okay, yeah, Emilio, go first.
Yeah, sure. So can you hear me okay, Fox?
Yeah.
Okay, so well, I hope let's see the sharing, because sometimes the laptop gets a bit down to its knees.
It looks good.
Okay, so well, it's going to be a very, let me put the timer. So well, thank you, of course, everybody for organizing this and for having the chance. I'm going to talk very briefly. There are longer presentations, longer slides, if somebody's interested about ongoing proof of work documents. And in particular, this is motivated by some data, and in particular, this is about the growth of scientific knowledge. And here I'm taking this survey, which is getting a bit old, is by Edward Dunn in the Notice of American Mathematical Society. But for this very short time, is actually basically, like, for example, in math journal papers, like by the time I retire, there will be 400,000 papers per year. And it's a 3% increase, it's an exponential increase on the production of math. And yeah, there is many problems with this, as you are all aware here. I don't need to tell you why this is a problem, in particular verifying these papers are correct. And on the other hand, we not only have to grow on scientific knowledge, but we have to grow on collaboration. And in particular, people have moved very, very quickly in the last times to a diversification in knowledge production. People are using wikis, people is using new media like Jupyter, people is using like the LLab. Last time I looked, this data is a few months old, there were 8 million active Jupyters not looking at GitHub. They're not counting like dozens of millions of non-active Jupyter notebooks. And in particular, I believe like a few months ago, like less in 2022, we reached a critical point. You have a lot of systems. For example, I'm happy to see Andrew here, he has a Scholar5, which has been a big inspiration. For example, in this work I'm doing to try to connect systems like a Scholar5 with Coq. But you have a lot of stuff. You have Electron, you have Coq, that we don't have the time. You have Nota by Will Krypton, like Athema, also like Clinical Polytechnique, Educera, which is an incredible tool, Waterproof, which is used for teaching in Netherlands, like huge collaborative mathematical books like Stacks. So really there is a lot of things, and I could name just from the last couple of months 4 or 5 more. Right, but the question is how far we are from something that is integral. And in particular, I tend to think of 3 axes here. One axis is mathematical writing, one axis is collaboration, and the other axis is theorem proving or verification, verifying documents in general. And we don't have a solution that addresses the needs, because if you look, for example, at computational notebooks, they're great for computational content, they are not very useful for verification. They're good for collaboration too. Overleaf, wikis stack, they have great features in terms of accessibility, but they don't integrate well with tools that can understand and validate content. Okay, and traditional ITPs like Kotlin or Isabelle, I think they lack many accessibility and collaboration features, and they are stuck close to the 80s, 90s models of interaction. And then the last year has really been a very, very hot topic. I mean, I'm not the top expert here in that area, but you can find a lot of workshop and a lot of interesting things. And in this time, a bit to explain.
Emily, can I interrupt for a question? Yeah, you mentioned accessibility as lacking in traditional ITPs, but then you mentioned that Overleaf and wikis and stuff had good accessibility. What do you mean by accessibility here? Are we thinking like screen readers and stuff like that?
Yeah, well, no, sorry. This I'm misusing the term likely by accessibility. I mean, like for a beginner or for a beginner on these systems, how easy is to start using it. Yeah, so I will be, thank you very much for the question. I will be very happy.
No, that makes sense. All right. Thanks.
Yeah, let's say like ease of use. I should use your right. I'm not an HDI expert, even if I'm trying to read some very basic undergrad books on that. But I mean, how easy are the systems to use? How accessible is, for example, for a mathematician to go and use Coq or to go and use Jupyter? Yeah, like in Spanish we say accessibility, so likely it's my mistake. But yeah, sorry. Yeah, I'm not talking about accessibility here, like in terms of people with problems in interaction. But yeah, I mean ease of use. And well, a bit actually, it's funny we're here because actually I started to get interested in this in 2013 with Software Foundations, which is literate programming. And for me, it makes a lot of sense, I guess for many people more. And then this is actually when it was a bit of a joke with Coq, which is a system that is it's based on this literate paradigm, and was actually with Software Foundations in mind, and it was done with mainly with Pierre Dubilov and Jan Pitt, Sahari Tsaki. Then a bit later, then we started to mess in Coq. We found some things. Then we did a different interaction with Clement and Panskonk. Like we did like Coqser API, which is a library targeted mainly to tools to communicate with Coq, and has been successfully used even with some pain points, but what's very interesting is here's a lot of experience has been used on a dozen or a couple of dozens papers on machine learning, on other user studies, etc. And parallel, this is where we are coming today. We have these two projects that we started with the three Blanqui and Rodolphe Lequipe at INRIA Saclay. We started to do a new user interface for the Lambda P-theory improver from scratch. And it was very nice because it allowed us to experiment with a new thing. We still didn't have the full experience to do that. But then in 2019, for example, I got a bit with the camera people, with the young people in Jane Street, with Ali Kaplayan, Jeremy Greenberg. We started to, for example, relate Coq and Dune and salsa like salsa and Rust. And this is when we took the topic of actually like with this Coq LSP, which is a kind at the intersection of a document edition system, a build system, and Coq. A build system in the sense like is essential to manage all this stuff. Then 2019, we did Coq LSP, which was basically a port of Lambda PLSP. Got frozen because they were trying to the Coq API that couldn't be resolved in time, so mainly here Vincent helped with the porting. And a bit we were in this, and that's in 2020 with the COVID, there was a big update of assumption, Lean got super popular, mathematicians got very interested. So this really reframed all the ideas I have. Also 2018, I joined INRIA. I reframed a lot of the ideas, so I was thinking, I was learning about incremental computing, learning a lot about those things, and it really spelled. And in particular, thinking, and also talking to my colleagues in Paris, we were doing a new team, PCube, and there were incredible discussions, very long discussions about how the proof checking of the future should be. And this materialized in 2022, thanks to a project that if will likely present, LibreApache, was a project that put a lot of effort in the education, for the education of Coq. Also Nick Berg in Correat, which is a project also to formalize data mathematics. And this gave a bit of motivation to say, okay, we have good use cases, we have a better understanding to actually resurrect Coq LSP, and we did a document checking engine which is called Fletch. And now we are actually it's very interesting how everything has started to coordinate and things have fallen into place. And now we have a platform which is very important, is web native. This is for two reasons. One reason is because to do human-computer interaction research, you have to have something like that, in my opinion, and for certain technologies. And for ease of use or accessibility, how easy to access to the tool itself. So we have a platform that doesn't care if you're running on the web or if you are running in your computer. It's multi-language, including human language. So it's not limited to Coq. For example, you can put in these documents Coq parts, link proofs, etc. Okay, it's very maintenance is one of the biggest problems. Has a lot of constraints in order to ensure it's easy to maintain, and it's simple enough as to not to be a big mess of code. And in fact, it's integrated with some other things with collaboration and package management features. Okay, this is a bit of things. And yes, and what we have today, we have a Fletcher, which is actually I'm very close to finish a paper about it, so hopefully you can find it in archive soon. It's actually a document manager, which is based on hybrid documents. By hybrid, I mean documents that are like literate documents, but it's a bit wider. This notion of hybrid is presently defined on the paper. And in particular, defines a notion of validation of a document, standards of a document, and it can be applied to other systems beyond Coq. In particular, in India, there are many systems operating in OCaml, so it's targeted at many other systems like Catalan, which is for law. And yeah, it has incremental and sees the Coq projects in a bit of a different way. Then you have Coq LSP, that is the interface to this platform, is adapted to all this experience, is adapted to present, to interact with editors like VS Code. And for example, this also has a printer which is very, very preliminary, which is based on actually on some requests Clement had on their API and some other feedback from people. And in particular, this is nice because one of the good things of this Coq LSP, it runs natively, also it runs in VS Code.dev. So it's not ready yet, but soon you will be able to type a dot in GitHub and get a Coq IDE in your Coq project. And then we have this Coq 2, which is actually this integration of Coq LSP, which is a really hybrid editor. It's cool how this technology we are really using it. And this is meant to actually, this Coq 2 is really the platform we're going to use for collaborative editing and for some more research topics. And yeah, I think that's it. So thank you. I would like to do a very, very brief, show you a very, very 1 minute demonstration. There is a lot of research topic to discuss, but I think it makes more sense to discuss individually with person interested or to join these weekly meetings we have and discuss more because today I don't think we have time for that.
Emilio,
so, yeah.
Did you say that Flash was used for Catalan or did this misheard?
Yeah, it's going to be used, not yet. Okay. Yeah, it's going to be used. That's the idea. Yeah, still, actually, we are to the point we're going to try the first integration. Yeah, And yeah, that's the idea. Denise came to IDRIF a few months ago, and we had this discussion. And yeah, so for example, the VS Code, you can get a feeling how it works, like Coq LSP in VS Code. It's very standard, so there is only one extension to show information about codes. Well, we also have some performance data. But well, basically, but you have features, but in particular, what is gone, you have like an obligation browser, for example. This is at some point will evolve to just so you can actually do a bit like a chat, like for these holes you see, this is telling you like the obligations pending. So this is very similar to Lean. As you can see this panel, you click and you get this information.
Yeah. It's already as a demo.
Yes, slow down the demo.
Yeah. Well, basically, if you're familiar with Lean, this is very similar. You just move in the buffer.
I don't think anyone is familiar with it.
Yeah, so there is no more, the whole document is checked. For example, if we open this famous document PIF, which is a document like this, 40,000 lines, you can see this is also shared with Lean, this extension, which is the file progress extension. So then Coq LSP is checking this document automatically, and you just need to go to the part you want. And for example, if you want to go with a goal, you go here, you see the interface needs a bit of work in terms of styling. And then you can work here, and you see it's incremental. So for example, things are not going to be rechecked. I like to do a demo with a simple example, for example, here. So for example, you see here, I can work break approve, and I have no problem. You see, error recovery and incremental engine, they are very tightly designed to work together. So for example, here there is a modular error recovery strategy. So this is, for example, another of the constraints the system has is designed to work with broken documents. Because this is, we are parting from a lot of quantitative and qualitative use case analysis, and we are trying to support exactly this case. For example, like imagine you are developing like a proof, you usually have like a lot of broken things, or you want to see. So for example, here you see, Coq LSP here, Fletch, will admit this lemma automatically. You have to do nothing. It says there is an incomplete proof, it knows there is an structure here, and then it's admit, and then you can edit here. You can say, okay, let's go, so you can try, okay, let's do a lim, and a lim n. Okay, so here you are. Okay, we have a couple of goals. There is still a lot of research to do how to present this better. And then, for example, we have these two goals, so we can just solve the first goal. But the interesting thing here you see is, for example, you see this catch hit thing. You see here, I'm editing a proof, but the rest of the document is not checked. And this is based on state-of-the-art incremental techniques, and in particular, it's very maintainable, and I'm very happy how it works. Okay, so this is the base of the engine. Like, well, I will be happy to do a more demo, but there is more people to do. But yeah, well, here we can finish the proof. And I think, you see, we finish this proof. And yeah, well, I'm not touching, but no, this is the proof finished. And in this, you can see, for example, this is not cached, for example, but this is, you see, the engine doesn't care. This is just how Coq managed the state. This says it's not cached because actually it's on a state that the proof is finished is cached. But then here, for example, I can do this. I know the proof is going to cache. But then going a bit to the web platform, which I like to show, it is very interesting. Here also, I didn't mention we support Markdown natively. So here you can have, this is the same thing, but in the browser. So here you can have your Markdown, okay? Well, here there is more fancy things, like completion. But here you see you can have your Markdown. So we can edit the proof. We can go here, we can like edit in the Markdown, and we can do the typical Markdown stuff. And this is thanks to the incremental system, like nothing is rechecked. We can continue here. It's funny once you have incremental Coq. It's funny, for example, you see, this is, for example, you can just delete this and nothing is rechecked. Coq knows, like Fletch knows this is like useless. But then if this is Markdown, then you can go a bit further up and use a Markdown editor. So this is Prose Mirror, which is a Markdown editor. So now here you're editing your documents like this normally. So you can do like bold. So we could write like woo, blah, blah. And here we have inside, we have exactly the same thing like Coq. So we can indeed, you see, in this Markdown document, which is not displayed. And in fact, then we can go and use like a bit of a better interface. And we can use, for example, this interface, and with this I finish, which is curve node, which is a Markdown schema based on Miss Markdown. So actually this is very interesting because this is, again, you have the Coq documents here. Here there is a piece of JavaScript, by the way. But we can do other more interesting things. So for example, we can do like, for example, inline mathematics.
Can you conclude now?
Yeah, and we can do inline mathematics. So for example, there is right now there are not linked. The Markdown and the Coq part, they are not linked, but this is some work we are trying to do to actually link in these references. Okay, for example, here you can do like a reference here, like a reference to code. So we are linking exactly. So that's the way we have to write Coq documents and Coq proofs like this, like with the regular writing. This can import LaTeX and it's work in progress, but yeah, it's like getting there. Sorry, in this I said longer time.
Okay, thank you. Shall we move on to Maxime and I forget who was going to be giving this bit.
I think I'm going to present.
Okay.
Work? Yeah. All right, so I think this is going to be a fairly short presentation just to give the main ideas behind the ongoing work on VSCOC. So we're currently a few engineers involved in the VSCOC 2 project, which is more or less like re-engineering the VSCOC extension as we know it today. Please maybe you use it already. So if we look back at the history of VSCOC, so originally it was developed by C.G. Bell at MIT in 2016, if I'm right. At least that's the date at which it was published first on the marketplace. And something like 3 years later, so I think the project was stale after this 2016 original publication for a few years. And around 2019, I just ported the existing code to newer Coq versions and released the new versions of VSCOC on the marketplace, so that people could still use it with newer Coq versions. And since then, it has been maintained by a few contributors under the Coq community umbrella. So even the releases are prepared by some people among these contributors, so it varies a lot depending on the periods. And it seems to be a fairly, I mean, in my standards, right, a fairly popular extension. So we have more than 16,000 downloads on the marketplace. We also expose the extension on the VS Codium marketplace. I haven't checked if we have analytics for that. I don't think so, but I'm not sure. So what do we want to do? So in a way,
just a quick question: do we know how reliable these numbers are? Because do we have a rough idea of the size of the community to get any sense of what these numbers mean?
So I don't know, and I don't remember if in the poll.
Yeah, we have survey results.
The survey.
So let me check quickly. Yeah.
So the numbers, the number I show here is what the marketplace gives us.
Reports.
I honestly don't know how reliable the number is. So the survey was saying about
so we have like 34% of survey respondents that said they were using VS Code with VSCOC, and it's 40% of newcomers for the newcomers definitions that we had.
Yeah, so that number on the marketplace seems low to me, because in fewer years, I think per general is in the order of like 40K or 50K, and it hasn't been in the Emacs marketplace for quite as long, and okay. I think it's getting less used today than VSCOC. So, but anyway, all right, cool.
So why do we want to re-engineer this thing? So this is something that was identified already when we ported the code originally, right? So the strategy was to first port to new Coq versions the existing architecture, and then see how to make Coq evolve and the extension evolve as well to simplify things and to make code more maintainable. So I won't go into detail too much, but just to give an idea, so the current architecture of VSCOC, so VSCOC 1, is designed around a two-component extension, as usual. So you have a VS Code extension that is a client, and you have a language server, which serves requests to Coq, requests to and from Coq, and relays it to either VS Code or the extension itself. But the thing that was a bit strange in this architecture is that the language server was not talking directly to the main Coq APIs. It was talking to a specific component of Coq, which is the STM. And the STM was in fact created, as far as I know, specifically for Coq ID in mind, and the parallel proof checking of Coq ID. And so the thing that is a bit strange when you read the code of VS Code today is that you have a lot of machinery, let's call it that way, to adapt the user interaction model of Coq ID on one side and on VS Code on the other side, and they don't quite match. I mean, it's really fundamentally not the same way the system is and the user are expected to interact with each other. So in a way, one of the first, and of course the whole thing is hard to maintain because you have this machinery, and if we want to make any of the components on both sides evolve, it's really, I mean, it's a lot of things that need to be changed for each particular improvement you want to implement. So what we would like to reach, is a simplified architecture where you have a language server that talks directly to Coq. Maybe it's not shipped with Coq, but it links to Coq, to the core APIs of Coq. And it exposes the requests and the services that are expected by the VS Code interaction model, right? So this is more or less what I explain here. So to summarize, we want the main things that current VS Code users see sometimes and maybe complain about or suffer from is limitations in terms of features that we can support, because some features that are the standard in the VS Code world, they don't really match this interaction model of Coq ID, so we just cannot support them. Or sometimes even you have strange bugs like your ID in some way is desynchronized with respect to the state maintained by Coq, and then you more or less have to reload the VS Code window and things like that to resume doing your proofs. And these bugs are actually very tricky because they are, in fact, in a way, they are a bit deep in terms of the nature of the problems that they expose, which usually are in this interface between the two incompatible user interaction models. And the other thing that I wanted to mention is that we actually got support from INRIA to have engineers like me, but also Romain, who joined us recently on this project, to make sure that we can, once we simplify this architecture, we can also support it on the long term in terms of maintaining the code base and making the extension released and up to date with respect to Coq versions. So to conclude the current status, so the development is very active these days. It happens on the VS Code 2 branch of the VS Code repository, so it's the same as the current extension. We have a fairly complete set of basic features that are usual for the VS Code in the VS Code world. So diagnostics, display of goals. So we have a structured tab-based view for goals, for example. We have a dedicated search panel. We have the parallel proof checking that it's a bit similar to what Coq ID does, but without relying on the STM. And what still has to be done is testing, making sure we are robust with like specific cases of strange structures of some Coq documents, for example, sometimes, and also optimize a bit so we can scale to very large documents. And also today, this work relies on the custom Coq branch for separating parsing and execution. So that work is 80% integrated in Coq already, but we still need to integrate the remaining 20%. And I think that's about what I had to say on this Coq too.
Someone raised.
May I have a question, Maxime?
Sure.
If a researcher wanted to build on, wanted to do user interface research involving maybe VS Code, is VS Code 2 ready for them to play with, or almost ready, or what's the schedule?
So, so the schedule is to get a first MVP, so first release with the basic set of features. So essentially be in parity with the current features of VS Code 1, but in this new architecture. So I think that's reachable in about 2 months, I would say, from now. But that's more, I mean, maybe the main target we have in mind for this is users of VS Code that may want to switch. Okay, it's not exactly the same as using VS Code as a base for doing research on user interfaces. Okay, so this is really an engineering effort, so we try to address the needs of Coq users and have a long-term strategy for that to maintain the interface and so on. And so, of course, you can also use that as a base. For example, if the nature of the work you want to do research on is to explore a new set of features that we don't support, but that is already addressed a bit in the VS Code world usually. So, for example, refactoring tools, something like that. So that is fairly easy to plug on, right, on top of this architecture. On the other hand, there are maybe some other kinds of experiments that you may want to do in terms of research in HCI and so on. So there, I think we need to talk with the Coq LSP effort, because I think maybe I don't want to speak in the name of the Coq LSP guys, but I think this idea of exploring designs in terms of interaction might be more in the spirit of that project.
Yes, actually, just this week, Coq LSP has migrated a lot of users from their API that, for example, doing machine learning or user interface. So in this sense, this was a big goal, but it's because we built on a lot of previous users. So for me, of course, was a good, actually one of the key points in Coq LSP was supporting all these research users previously in their API. So well, actually, this is in this sense, yeah, I think it depends about what your constraints are. I don't know a lot about the architecture you have. So I guess they have very different architectures, is my impression, even though I don't know the architectures that you're using, guys. So I guess it will depend, likely depends what are your, for example, like for machine learning, I would rather use something like this Fletch. Depends what you want to do, yeah. But yeah, I don't know a lot about this, so you have to correct me, Maxine. I don't know what kind of API you are offering to users.
I think it's fair. It really depends the kind of, that's what I mean by features. I mean, the kind of areas you want to explore will probably determine which of the projects are best suited to building on top of.
Thank you. I think Clément has a question.
Yeah, I have a bit of a follow-up question to understand better the division between Coq LSP and VS Code 2. In that list of features you actually have on the slide, I would have expected diagnostics to be something that comes, with heavy quotes, for free once you have diagnostics support in your LSP implementation, whereas goal display and the search panel, that makes sense that it would have to be implemented in the IDE. Can you comment on that?
Yeah, so that's right. So essentially, if you look at the protocol, and I think this is similar in Coq LSP and VS Code 2. If you look at the protocol that is extension speak, a subset is really LSP, so it's part of the LSP specification. For this, the only thing you need is your language server to support emitting the request notification and responses for this fragment. So the diagnostics fall in this fragment. So when I say we implemented diagnostics, that's in our language server, but in the client, you don't have anything, almost don't have anything specific to that. Whereas on the other hand, goal display, for example, is not something that is part of the standard LSP. And so there you have both the implementation in the language server and in the client code that explains how to render these goals and display them in VS Code.
That makes sense. A follow-up question on this is, last year when I worked at AWS, I was involved in the development of the VS Code and language server, VS Code extension and language server for Daphne, which ran into some of these same issues of Braille proof checking and displaying Daphne-specific information. And Amazon currently has, I would say, the equivalent of maybe 1.5 or 2 full-time engineers working on that extension. I wonder if there's, in the LSP server implementation, there will not be code sharing. But I wonder if in the implementation of the extensions, there might be some code sharing, and in the extensions of the LSP protocol, there might be some synchronization as well. Because I think a big push for LSP would be that there would be some degree of unification between the custom languages that editor extensions were speaking, and now we're having the situation where proof assistants are each creating their own little set of extensions of LSP for things that might be shared between LSP, between proof assistants. And in fact, it might be a good outcome in a few years if we could have a standard extension of LSP for proof assistants that we could share with Lean and Magda and Daphne.
So I see two opportunities in what you said in terms of sharing the work in a way. So one is the implementation in the extension. So some features of the extension that is very close in all these, very similar in all these projects. So this is an area where, so for example, the fact that we are collaborating with Roma, we are trying to make something fairly robust and fairly full-featured. For example, the goal, the tab goal that we have. Your keyboard, sorry, is it? The tab view that we have to render goals is actually using React behind the scenes. So we have something that is fairly reusable, very flexible. So supporting different use cases doesn't require you to change a whole lot of your logic. And this was also a motivation for collaborating with Romain, who was already developing in React before. And so there, I think there are really opportunities. So this was about the features in the client extension. Okay. So then, in the protocol that is used to exchange between the language server and the extension, there, at least for VS Code 2, we went in a bit of an ad hoc way. So I don't know, Emilio, I remember that originally, when you started talking about these LSP things a few years ago, I think you had in mind that we could also reach a fairly standard superset of LSP or something like that for you.
I don't know if you're aware, Fox, of there is at least 3 times I discussed with Macarius and with Lean people, and actually, for example, I have adopted for Coq LSP, I have adopted the Lean protocol, the extensions of the protocol. I will choose the big thanks to Gabriel Efner, by the way, and thanks to Macarius, because really a lot of this. So there are 2 things, for example, Coq LSP can be used within the standard. This is the 4 of discontinuous checking. So actually, in fact, well, there are some extensions, but you can load it in Beam or in Emacs. So instead for this gold panel that you can present in the standard, not so good. But yeah, there is a bit of a problem because I was talking, so there is an issue, by the way, on the fact of Coq LSP, there is an issue where the last discussion has happened. So Microsoft people were not interested in proof assistance for the extensions. But then, for example, I don't see, for example, the Lean info view and Coq LSP info view. This is something, so info view comes from GSCoq, so it has a long history and it's written in React too. It's complex because actually the way Lean is doing the things they're using like an RPC protocol, this is not, so I think this is not an easy way to achieve Clemanian sort. Yeah, it will be a very long discussion, but I've been talking since 2016 with Macarius, we invited Macarius Wenzel here with the Lean people, etc. So unfortunately, I think it's not going to be easy. I don't see, for example, a way to make the Coq info view and the Lean info view to converge. Even if you see they look really identical. Well, of course, the Coq one is very much more bare bones. But they are using an RPC, that RPC model. This is, for example, is a protocol. So there are some technical differences. So yeah, I don't know. But there is an issue and a discussion. And actually, Lean people were very useful. And for example, the file progress extension is something I would have never thought of that, but this I took it from Lean, and I think that users love it. I would have never thought, So yeah, I don't know.
Cool.
But yeah, it's kind of tricky. LSP as for proof. Yeah.
Can we ask you a question, Clément? Given your experience with Proof General, do you think Proof General today it's getting more restricted? I think. From what I've seen, it's supporting less provers than before because it.
Proof General basically supports Coq and EasyCrypt, and that's it, I would say.
Yeah.
Yeah, and I think that's just because the protocol that Proof General has is old and creaky, and something better would be better. My intuition is that we'll rip out and rip that out and move to LSP once the LSP support is good. There's plenty of things in Proof General that are worth keeping, like the indentation support, for example, is pretty nice, and I don't think we have a good story for indentation out of Proof General yet. But otherwise, the syntax highlighting is pretty good too. But although I guess you could argue that you can do semantic highlighting from LSP as well. But the document checking, I think we would love to just defer that entirely to LSP. And I think the Lean folks, for example, just use fly check to display error highlights. So if we could move to that, that would be great. I will be, as a Coq user, a bit sad to see the watermark model go away. I kind of liked the idea that there was a clear position in my document where I was stopped, but I understand that the times are very high.
This is an interesting question because we thought a bit about it. I think it's fair. I mean, designing the underlying scheduling engine for this model is probably the wrong idea nowadays, that we want to support more flexible interaction models. But on the other hand, so if you support the continuous checking paradigm, you could still emulate, in a way, so a region of the document on which you guarantee, so a contiguous region on the document, on which such that you guarantee that in this region everything has been checked. Okay.
But I'll give you a very concrete, yeah. Sorry.
So it just concretizes an invariant of your system in a way, and you can still do it in a smart way such that if you go back and forth, then you still don't recheck things because you hit caches, or we do it in a more static way, but it's the same.
I'll give you a very concrete concern I have with that model. Out of my laptop's battery, I get roughly 2.5 hours of Daphne development and 4.5 hours of Coq development. And that's in part because while I'm thinking, Coq is not like exhausting my battery trying to prove things down the document. It's possible that with fancy caching and everything, you can save a lot. My experience with the continuous model in Daphne, at least, and maybe the caching is not powerful enough there, is that I get a hot laptop that makes whizzing noises throughout my work session. Unlike Coq, where it does that just when I'm waiting for a proof.
No, it's very true. I mean, there's no magic there. If you do continuous checking all the time, you will spend a lot of energy with.
Yeah, but this the solution Macarius implemented in Isabel works pretty well, and actually LSP developers I submit a request to them and they have accepted. So there is a solution. So this is not a problem because actually we have added. So it's new, really new in 3.17. So actually what we do is lazy checking based on the viewport. And that, along with other feature which is coming in Coq LSP very soon, which is like, is a bit technical, it's about like lazy checking of proofs. So actually it's possible to do continuous checking in a lazy way. And yeah, the performance is much better. Isabel has been doing this for years. In fact, many of the features here I just copy straight from Isabel. So Isabel does it doesn't check anything until you scroll to that part of the document. So, and then LSP, that was important, this is added to the standard in 3.18.
So correlating this to scrolling, either you love it or you hate it.
But this is an option for the user in Coq LSP. Yeah, but the user, but not for example, but Isabel, nobody complain about that. Isabel checks when you get into view and nobody...
Can we correlate it even further to the specific position in the document that the user clicks on or press Control-C, Control-Enter to go to?
Yeah,
okay,
certainly you can.
May I suggest that we pop up at this point?
Yeah, but thanks for
the conversation was useful, but it was going down the rabbit hole.
And in fact, I'm going to have to wave goodbye to everyone because I have to jump to another meeting at 4.
Oh, Clément, I'm sorry. I had put you almost next, but well, do you want to go next? Do you have 2 minutes to speak?
I have 2 minutes. Yeah. Okay. Great. Hi, folks. So back in 2015, I think I gave a little presentation on Company Coq, and I complained at the time that I showed a cool trick where you displayed latex math instead of a Coq proof. And I said it would be great if we had a collective discussion on exactly how to make this easy. But at the time I was working for someone else, and hence my priorities were a bit different from now. Now I have my own lab, so I get to run straight into the wall of my own volition. And so what I would like to spend some time doing in the next few years, and Chardul, who's also on this call, I think is interested in working on this together, is thinking a bit on how we can go beyond textual notations. So we have a really good story in Coq for custom notations that are very easy to define and widely used. I would like to get a graphical version of this going. And I'll give a very short example that I think many people on this call have already seen, but for those who have not seen it, well, you will see it now. Share application. Let me see. Window this.
That was Daphne.
It's running a proof in the background.
Daphne kicking.
Not enough resources for.
This is the textual notation of Clément.
Very well said.
Great. So today I learned that I can crash Firefox. So I'm going to only share my whole monitor. All right. Can you see my monitor? Yes. Excellent news. All right. So here's a small proof that was written by Arthur Charguero a while back. It does manipulations of separation logic predicates, and it has a few custom notations that are not super relevant.
We have not seen your screen.
Well,
it's frozen.
We're seeing the screen, but it's frozen.
Okay. All right. Let's do that again. Share screen.
Yeah.
Share screen.
This is what you're trying to.
It's the typical bug.
You can freeze or crash.
Yeah. No, it's
That's good. Here it is.
How about this? Can you see a Chrome window?
Yes.
Yeah.
Okay, excellent. So you should be able to see some separation logic predicates. These things describe a graph, right? So there's a bunch of pointers on the left and the objects they point to on the right, separated by these little wavy arrows. When you do a proof like this, you are stepping through predicates of that form. It's really hard to understand what this means, even with the existing support for notations. What I'd like to move to, and you see some at the bottom as well, what I'd like to move to is representations that are closer to this and to that. And so there's a question of how do we enable users to define such domains? How do we find good representations that are stable throughout a proof? And how do we make it reasonably not too painful to actually define these things? And so the example I have here is that you can step through the proof and see how the graph evolves, and that allows you to understand hopefully better what's going on in the proof. So that's what I think I'm going to be working on in the short term on Coq UIs and interfaces. All right. That's it. And I also have to jump away. So I will leave Shardul answer any questions if there are any. Good luck, Shardul, and bye, everyone.
Can I ask a
Any
question?
questions for Shardul?
Yeah, I have one. So the rendering, okay, as a graph, I guess it would be on the user interface side, right? I mean, would it be in any way specific to Coq or?
No, so we're thinking of starting by just trying to figure out how to, even conceptually, like forget the UI part of it, how to conceptually come up with a graph that is stable throughout your proof, because the reason it is hard to follow is if it keeps jumping around, it's still the same problem. So the first step is, I think, figuring out a good way to think about graph layouts for proofs that are already finished. Then you could think about graph layouts for proofs that are in progress. And then I think much further down the road is the actual question of UI of, okay, how do we actually show these graphs?
Fair enough.
So there's no question of how this integrates in the dialogue yet.
How this integrates into what exactly, sorry?
The dialogue between the user and the prover. The question that the LSP question is not apparent here.
Where Clement? Go on.
Yeah. So one way to think about it is that, do we want these graphs to be just a representation and you still keep interacting with the text-based form of the proof, or for certain domains like separation logic proofs, would the graphs be, or would the visual representation be powerful enough to just let you interact with it directly, and so that it becomes the way you interact with the theorem prover, rather than trying to write a proof crate or construct a proof term for certain, like very limited, very focused domains of proofs.
Yeah, but Clement, but I discuss about this with Clement, this question of integration. So actually I mentioned, in fact, it's true the last time we checked was in 2021, Sahar, Clement and I, but in principle, yeah, at some point we should be able to communicate these things with the user interface. Because
okay,
actually...
No, but I was just asking the question to Shardul whether this was the topic they were working on now. That there will be solutions, I'm perfectly convinced. I just wanted to know what were Shardul and Clement working on just now. And that's the only question I was asking.
So, I mean, so to be perfectly clear, like we have not started any actual work about this. We're still talking about what exactly is the scope of the thing we're going to do.
Okay, thank you.
But, for instance, for what you have shown, are there rules which produce the graph? There are elements which translate the...
No, I saw that demo was entirely made by Clément, so I don't know what's behind it, but I think he described it as a big hack.
All right, shall we move on to Yves?
Okay, I prepared a few lines, which you should be able to see in, when I click on the right button. Yeah, so it's just a mail I sent to myself, so that you have some visual. So the first thing I would like to mention is that there is work also done by Pablo Donato, whom you saw, Benjamin, at the Coq workshop with Benjamin Bernard. This is part of a project which is headed by Nick Baer, who is present in this conversation. And the goal would be to be able to use graphical manipulations of diagrams to do proofs based on diagram chasing. I hope that Nick confirms that's the basic idea. So in the project that Nick is, the topics around proofs in category theory are going to be studied, but there is one specific aspect on user interface, and I am discussing with Pablo and Benjamin Bernard on this topic. So that's the first point. Just to mention, Emilio and Hugo, who are also present in this room, and Enrico are also part of this Korea project that Nick is studying. The second topic that was already mentioned by Emilio is that I've been organizing a project, a multi-team project, but mostly centered around INRIA, around aiming to make the theorem prover Coq mainly a good tool for teaching mathematics. So if you want to talk about teaching mathematics, you have to remove the context of, until now we have mostly students to computer science students. We have mostly taught to computer science students. And the objective of learning how to use Coq is basically part of the topic. But if you want to teach mathematics students, you would like the objective of learning Coq to be less prominent in the thing. So having things that are easily usable, what Emilio misnamed accessible, but I don't know a better word either, is at the center. So in this topic, I managed to get funding to work on VS Coq. So this explains the work on VS Coq 2, which I am pushing in a way. I also managed to get funding for Emilio so that he could work on Coq LSP. So the two projects are basically both related to this this project, for which I chose a name which is Liber Abassi. If you want to know about the name, we can discuss that later. So one of the things is that we might want, if we want to teach mathematics, we might want to do the same thing as mathematics teachers have been doing for a long time, which is to have the same topic presented in different books, depending on the audience for which they are targeted. So in this case, we may have to cater and embrace duplication of presentation of the same topics. So this means that this is what I would call voluntary duplication. We may have to understand what this implies in terms of development, but I'm not sure it's really a question of user interfaces. But for newcomers, one of the important things is to have fast access to existing data. This is why I think there should be an effort on search. And actually, Maxime and Romain are already acting on this topic. But I think there are a lot of funny things that could be done around finding the right theorems depending on the context in which you are working. For example, you could use machine learning tools to have good suggestions of what theorems could be useful in your given topic. And do we really want this to be done, or do we want to let the user have to discover it for themselves, because having to discover is part of the way they can learn the topic they are learning. So we have to understand at what time we want to really assist them, and at what time we don't want to assist them because we want them to learn. So there are also, I think, in terms of how you present the proofs, there are a few things that need to be done. Some tactics, some typical proofs in math are still not really well covered by tactics, but MathLib is already progressing in this direction, the lean community. What are called the calculating proofs. How do you present them with correct tactics? And another thing that comes to my mind is that when you want to teach mathematics, you don't want to teach how to do the steps, the micro steps in detail. You want to also to teach students what is the big structure of a given proof. And I have the impression that right now, Coq, the use of Coq pushes people into looking at the details, but have no good way to highlight what is the big picture. So I think that we should work on this. And Emilio already noted that we have to work on notebooks, but Guillaume Mekion, who is also present here, and Asia Maboubi also wrote that as part of their project in the framework of a grant from the European Community, what is called an ERC grant. So this is called Fresco. So I just wanted to mention that all these topics are present. I have been discussing with a few of these people, and I can give pointers to people if they want to. So another thing that I think is really important for the future of the Coq system is to reduce the, how would you say, the heterogeneity in all the libraries that exist for people. When newcomers arrive, they don't know which library to start working with, and very often there is no good choice because most of them are only answering the problem at 80% or 90%, and they don't overlap completely, they don't subsume each other completely, and we still have had a lot of work of exploration, and this is costly. And I think we would need to be able to work on how do you unify these things. And I think for this, refactoring is a big topic. And if you think about it in terms of user interfaces, refactoring is a mine of topics. Here I'm just giving two ideas. We should have easy ways of modifying code, so you can start from spell checking, where you only look for replacing strings by other strings. You could look at replacement based on regex, but you can also look at replacement based on syntactic patterns. And in fact, I come from 20 years ago, I worked on a topic where we had access to these syntactic patterns in a very easy way. And you could build menus on top of this with rewrite rules and things like that. And maybe we could have rewrite rules that are only doing syntactic operation, but using a meta language like CoqLP or MetaCoq to check whether the rewrites are worthwhile or not. Not necessarily, I mean worthwhile because you may not have a guarantee that the replacement is safe, but at least it makes it easy to propose faster to the user what are the right positions to doing the replacement. So, and another thing that I've been noticing also, and it's a bit less important now that since we've changed to Coq releases on a time base, the porting from one development to the other is less costly than before, but it would still be very useful to have tools that make it possible to understand how can you rerun an old development in a new setting where theorems have changed and maybe some APIs have changed and you want. So this is basically what you need to do in refactoring. So this is, in terms of user interface, what I foresee is that this requires being able to execute the same script twice in lockstep, but in different settings, and do operations in one of them according to what we see in the other, in the execution of the other. This is something I have to do very often when I want to port my code. So there was also, it was already mentioned that there should be interfaces with machine learning. And so I know in the past, therapy, which was developed by Emilio, has been used for this kind of things. One of the things that I've been discussing for the last 3 months with a specialist in machine learning, and basically what I see is that he basically wants to learn from past proofs to be able to reproduce them in a new context. But this is not what we want. When we have done a lemma, we're finished. We don't want to see the proof of this lemma repeated many times. We want to find all the places where this lemma can be used, which is not exactly the same question as repeating past behaviors. So in this respect, I think, well, if we have the right interaction with machine learning people, this is what we should teach them. We don't want to be learning from past behaviors to just reproduce them, changing what needs to be changed. We should learn how to reuse new lemmas every time we produce a new lemma. And so this is among the questions that I don't know if there is I don't know why I put this here, because I don't see what is the user interface issue there. But obviously, if you want to work with machine learning, well, machine learning can help in suggestions. But that was, yeah. Maybe I should stop here.
Yeah, that's a good place to move on to the next. I think the next is Nick.
Okay, so. Sorry, apparently it do not see the slide, sorry. Doing something weird. Can you see my slides? Sorry?
Yes.
Okay, thanks a lot. Yes, so I mean, I'm very happy that I got the invitation extended by Benjamin via Emilio, and thanks for having me here. I guess I'm more of a guest here in the Coq community, but but I will be heading the CoReact team as scientific coordinator. And maybe just to give a brief context, so I'm an applied category theorist, you could say. I mean, I'm working in theoretical computer science, and I'm expert in categorical writing theory. And this project started from sort of one of these after COVID office discussions with Emilio and Hugo and many others. Because we had this stage in the development of this theory where we have a very clear layering of concepts for this categorical writing theory, from a very high level abstract one in double category theory over to one where you see the actual semantics of the theories as some sort of double push out of writing these sort of things. And then all the way down to certain applications of the writing theories, for example, in biochemistry or in organic chemistry or social network models. And all along, the question was that, I mean, we are a relatively small community, we as in categorical writing theory, but we use a lot of different concepts from category theory all the way down to algorithms, and not much of this knowledge is today represented. I should say that maybe, because it's not well known, there's a 50-year-old research field, but most of the publications are more in conference papers. That's a bit unusual maybe because it's such a small community. And then basically we discussed how could one, I mean, the main problem here is that if you this kind of knowledge is nowadays presented more in sort of a wiki environment like applied category theory, and then when discussing how one could perhaps leverage Coq to for example verify some of these proofs, even to have a library for this sort of very general kind of category theory, then we started discussing, and as you see here, there's quite a few members from the Coq community then joined our efforts. I should say that this is a French A&R project which will run starting from March for about 4 years. We will have several postdoc positions and a PhD position, and you will be able to follow the developments over this this web page, which currently just links to some sort of working group format, which we will start when the project starts, and we had already some few talks. And so the main point about this project is that we discovered quickly when brainstorming what one would need from Coq to do this sort of category. We will need some sort of diagrammatic reasoning in Coq, which apparently is currently not supported, if I understand well. We of course need a very powerful category theory library, which again is part of the project. But in particular, from the user interface side, we discovered that the way we will need to interact with our community, who are not all Coq experts, is some sort of interactive database and wiki system. And so this is basically leveraging from current state wiki systems, and which are reused for category theory. These are more sort of the traditional wiki engine. Perhaps sometimes there's a nice design where you have a sort of textbook which is written in something like LaTeX with a special format, and then you can extract a wiki page from it. But by no means are we anywhere close in this research field to have anything like a library of Coq proofs that are easily accessible. And so then the other observation, when I, as a non-Coq expert, looked at what exists together with Emilio and the others, you see I have, for example, this Coq Comi library. There's this nice view of concepts in the library, but the deeper you go into the library, there might be some level where you still have human readable code, but then eventually you read, of course, a Coq document. And I mean, I think it was mentioned before, if you're not a Coq expert, more like from the mathematics side, then maybe this is sort of the end of the interaction with the user. So we have this vision that we will develop a prototype, or hopefully a working platform for a Coq-enabled wiki system, where we will have in mind from the start that this will be a collaborative document or collection of documents where some parts will be written by experts from the domain, like by mathematicians or computer scientists. But then it needs to be enabled that you also have a way of attaching Coq proofs to the human readable bits. And here's where Emilio's JS Coq is going to come in. And more importantly, from the point of user interface design, which might be new, because I think JS Coq is already quite established. But what we will try to do is to also have a graphical editor. I mean, some of you might know this Quiver app maybe, where you can edit diagrammatic proofs on commutative diagrams, I mean, in particular. And the idea here is that we will try to develop a parser for such commutative diagrams that will produce you Coq proofs from just a diagrammatic entry. And what I mean, for example, if you see here, it's on the right is just the universal property of a pullback square. For example, you have certain diagrammatic configuration that if you extend the pullback square as shown, you can guarantee existence of this dashed arrow. And that is sort of like a very large proof macro, if you will, which graphically is quite clear, but I mean, how to parse it into Coq, and I mean, use the right version of a category theory library and so on. That is something we would like to automate. Of course, there is on the JS Coq side, I think Emilio, as he already presented, there is this idea to have something like this curve node, like this editor, this visual editor in a web browser running, also for maybe making easier for people to transition to experimenting with Coq code. But and we will try, of course, to stay as close as possible in philosophy with this Coq community, with whichever library we will develop. And maybe just to, I think I want to close with just mentioning that this kind of theory we are trying to formalize here, I think it's very interesting because for Coq also as sort of a use case, as sort of a large collection of examples, because the kind of category theory we will implement ranges from relatively elementary category theory over something like double category theory and vibration and so on. So I mean, it'll be a relatively comprehensive set of category theory which will be used in the theory. So maybe this can drive also a little bit the experimentation with developing sort of category theory libraries. And finally, I wanted to mention that currently, if you go to Coreact Wiki, you will get a link to the Scatter Exact working group. This is basically our format. We will host working group sessions, I hope in a semi-regular format, where you can also see the progress of the project. And of course, I hope over time we will interact also with the larger Coq community at various points. Okay, and with that, merci beaucoup, and thank you again for the invitation.
Great. Questions or thoughts?
I have a question. So did I understand correctly that part of the idea, particularly the graphical interface part of the idea, is that you want your users to interact with the proof, with the graph representation of your proofs, but those graphs or those diagrams themselves represent proofs, and so you want to have some sort of automation that behind the scenes is going to convert that the construction of a diagram into a Coq proof. Is that correct? Did I understand correctly?
Yes. So what we envision is that in this field, it's typical that, for example, you have a sort of small or maybe large set of possible graphical manipulations for which you have a justification because, for example, you're just to give a quick example, having such a pullback square requires something from your underlying category. Let's say you have a sort of a statement, I am in a quasi-topos, say, so I'm allowed to take certain kind of pullbacks. Once that is enabled, we will have an editor which for some part just quotes from a category theory library. Basically, you say, now I'm in a quasi-topos. Then you have a collection of graphical moves you can perform on a commutative diagram. And so we envision to have an editor which can suggest you, based on a region you select in your commutative diagram, here, for example, such a configuration where you can apply the script which says, well, if I have a pullback square and so on, I can get this extra arrow. So it's really a relatively complex idea, I suppose. It goes a bit in the direction, as Yves already said, that you need some new kind of way of thinking about proofs when you have this hybrid mode, where some part is traditional Coq, I would say that's category theory library, but some part is the interactive construction of sequences of manipulation of commutative diagrams. And I think that's maybe the really interesting part for user interface design.
I suppose another way that it gets even harder is once you've constructed this interactive proof, you then need to maintain it later and make it readable and fix it when it breaks. And so you need either a robust way of representing the graphical information so that you can replay it and interact with it, or you need some kind of bidirectional, some kind of isomorphism with a textual representation. Which way are you leaning?
Exactly, and so the idea here is because I mean again, like we are a specific. For the moment, the idea is that we will collectively write a wiki. In that moment, we need some diagrams as the actual depiction of the human readable part. And the idea is if already the sequence of diagrams that prove something is actually the thing that is in the wiki, which you read, basically the link between the shape of the diagram and, I mean, it'll be that diagram we prove. So it's going to be like so in that sense, we are not saying any other diagram you could write for the same proof. We are sort of limiting ourselves a bit because, as you say, otherwise it'll become unmanageable. But still, then I mean, you have a way of suggesting the available proofs. The idea here is that writing down even one of these commutative diagram proofs has a lot of, I wouldn't say like overhead, but I mean the piece even of saying it's a commutative diagram in Coq looks impressive. I mean that's already for a non-Coq person is quite surprising, and we want to even allow for an outside Coq users to even write something that could then be proved. So to automate this translation is basically the hope. Will facilitate the entry point into Coq a little bit for mathematicians. And that's quite a huge number of proofs in category theory, I guess, which really, really benefit from having a graphic, because that's the practice in the field, these commutative diagrams. So I think it's an interesting mode of interaction with Coq if that works. So, yeah.
All right. Thank you, Nick. Shall we move to Jessica next?
Well, I can try to share. Oh, sorry, I have to toggle some setting. Well, sorry, this is my first time using the Cisco. I don't know how to get it to tell it that I'm fine with it sharing my screen. Okay, maybe you can swap me with the next person and I'll try to figure this out.
Okay. Then that would be Jesper.
Okay, so let's see if I can figure this out. Yes. All right, I need to reopen my app apparently. So,
Oh, dear.
Who's next?
Jessica and Jesper are the two that are left. So we'll see who wins the race.
right, I'm back.
You want to go?
Sure, unless you've already got another one. All right, this seems. I already have. All right, can you see this?
Yes.
All right, so I'm going to be very brief. This is the project that I applied for funding for from the Danish Research Council. I will know in May if I get it or not. But the general idea is to try to get sort of Coq and program verification to go where Verifast and Daphne have gone before, where you can actually sort of write your C programs or your Go programs in VS Code, in your standard editor, and write your Coq proofs in VS Coq in your standard editor, and actually have these things talk to each other. So it's a 2 PhD project where one is supposed to work on sort of getting our multi-body session type iris work integrated with Tassaroti's perennial and their implementation of Goose. So that's sort of the theoretical side, and then a more practical side where we try to get the verified software tool chain, Refine C, Bedrock C++, and Goose sort of integrated in VS Coq. The blue is supposed to sort of be what we as a part of the project are going to actively be working on, and the blacks is sort of may very well be extended during the course of the project, but not as a consequence of us. And the orange arrows are supposed to represent connections that simply do not exist at the moment, but that we will have to create. So in general, we want to see if we can make program verification a bit more accessible, because I mean it's really coming a long way. So I think I will leave it there, right? So the main weakness of the project is that we really don't have a UI expert on board. So lots of excellent Coq developers and Coq engineers. But Andrew, I don't know if you're still here. I would really be interested in talking to you later, regarding sort of how to set up the UI regarding this, right? Because this, if I were reviewing this is what I would point to as a weakness of the proposal, right? Other than that, I have a few master's students present, and we are sort of looking for a master's project somewhere in this vicinity, right? So they probably have plenty of ideas themselves, but I think I will leave it there because we're already running a bit late. But if you have any questions, I'd be happy to take them.
Oh, the image disappeared already.
All right.
All right.
Jessica, are you?
She was gone and just rejoined. Give her a second.
I think I figured
There she is.
Is it my turn, or I missed
It is
a
your
few
turn. Are you
minutes
ready?
of the meeting? Yes,
Yeah.
sorry, that was really hard. Let's see, I'm gonna share my whole screen, and then if I click this, do you see it in full screen?
Yes.
Yes.
Oh no, and then wait, it just went away. What? I'm so sorry. 1 second. Okay, let me try again, and if not, I just won't do it in full screen. Can you see?
Yes.
Okay, sorry about the technical snafus. So I'd like to talk to you a little bit about the early ongoing work we've been doing around proof assistant usability at the University of Pennsylvania. And this is being undertaken by Andrew, Benjamin, Harry, and I. And so the question we've been asking ourselves recently is, what does this process of reading the proofs produced in the context of proof assistance, what does this process entail? And so if you have a simple example of a proof of the commutativity of addition, there are sort of several areas of knowledge we might need the user to have to be able to fully understand this. There's some amount of mathematical background needed to know the definitions and symbols, as well as proof techniques like induction. There's some amount of programming background, understanding the language constructs like tactics, being able to do standard programming search and navigation tasks to find helper functions, in this case helper lemmas. And sort of the most interesting category perhaps is the expertise needed to navigate the specific unique setting of proof assistance. So understanding details that might come out in the mechanized version of a proof that wouldn't appear on pen and paper, things like tacticals and bullets to shape and keep track of the structure of the proof. And critically, we've only been talking about the proof script here so far, but of course, it's vitally important to be able to interact with the assistant in a way to see the proof state, and this sort of stepping through the proof we think is a bit of a double-edged sword in that you're giving the user a lot of potentially really useful information about how the proof works, but at the same time, with this increase in the volume of information, there's an increased risk of the user not knowing where to focus their attention. And so, sorry for my bad transition, but the thing we've been thinking about in terms of proofreading, it seems like that users we really expect a lot out of users during this proofreading process, and so the natural follow-up is, well, what can we do to shift some of the burden off of the user and onto tooling? And so, of course, there's already a lot of really interesting work in this space. Just a couple of examples here for Coq and other proof assistants as well. And so we think there are useful opportunities to evaluate how the current tooling impacts things like readability and comprehension. And by evaluate here, we would mean through, for example, user studies. And of course, we're also interested in exploring opportunities for new tooling. So one area we've been thinking a lot about is the interplay between automation and readability. So for example, we have these proofs here from Software Foundations of the same theorem, but there's this much more verbose version on the left, this much more automated version on the right. There are advantages and disadvantages to both, but you can imagine a situation where, for example, a proofreader is met with this version on the right, but actually wants to understand the proof in a little bit more detail. Maybe they want to know how a particular case works, or something in the definition changed, and now they need to debug the proof. And in situations like that, the reader might need to uncover some of the details that have been hidden during this automation process. They could do that manually, but that would be sort of rather tedious and potentially error-prone, and so we're interested in tooling opportunities in this space. We have two very preliminary demos. The first is in terms of restructuring proof scripts. So in particular, this is a demo of semicolon unraveling. And we would naturally want to extend this to other tacticals and more complex situations as well, but giving the user control over the structure of their proof. And not just the proof script, but the proof state could be augmented as well. Currently, when you step through a proof, you sort of observe how the proof state changes in reaction to the tactic, but we might want to slow down a bit and get a little more information about what it is in the state that actually allows the tactic to go through. So we've been fiddling around with the idea of half steps, which highlight the assumptions in the context that are used by a particular tactic. So in the case of something like apply, this would just have the effect of telling you where to pay attention. And in the case of something like auto, this would highlight information that would otherwise be hidden in the proof term. That's a quick high-level summary of some of the ongoing work we've been doing. This is sort of all framed in the context of proofreading, but we're more broadly interested in all questions related to proof-assisted usability. So I'd be really excited to continue conversations anywhere along that vein.
I have a question.
Please.
So in what you are presenting here, you are modifying the Coq script to Coq script without changing the language. There's no objective to produce, let's say, mathematical reader input, for example. Natural language or pseudo-natural language. That's not your objective.
Yeah, so I think there's really interesting work to be done with generating, if I'm understanding correctly, natural language versions of proofs as a way of improving readability. I think there's sort of multiple use cases going on, right? If you want to understand the mathematical content of the proof, I think that could be really interesting, and I'd certainly be curious to see how that would work in that case. One case we've been thinking a lot about is the situation where you're reading proofs to write proofs. So, for example, reading example proofs to learn new tactics, or reading proofs in the context of a very tight feedback loop with debugging. And so in those contexts, shifting away from the mechanized setting would not really meet those goals.
Okay, I understand now better. The two use cases that you are given are very good.
All right, other questions for Jessica? So I have maybe a more general question for everybody. We've heard about a number of kind of ongoing or planned research efforts in the broader community, and we've heard about some things going on within the Coq team. So what do we need to do to make sure that the right people are connected up?
Good question.
I don't know, Benjamin. I interacted as I have this interface to Coq. I don't know. I have no clue because many times I tell people this is not a bad idea. Why don't we tweak this in a sense? And they prefer to spend 6 months doing a Coq parser or something. So I have actually this is a very hard problem to me. I don't know. It's a very cultural thing. So. It seems it helps to put official things on the team, and maybe the Coq team could have better communication, that's for sure, a better web page and a better organization, but this is something we've been discussing. I think people doesn't get a lot of pointers when they visit the Coq web page and what are the projects, and it's very hard to understand for them what is the panorama. But it seems like a very hard problem, because also, for example, with machine learning, people is very competitive, for example, so yeah. Sometimes research is very competitive, so that's also a bit of problem to connect people too. They like to keep things for themselves.
To start with, for instance, if we make such a meeting every month or every 2 months,
yeah,
it would help at least to synchronize better and have a community.
Yeah.
Is this what you had in mind?
I'm sorry, I missed some of that. Was that Hugo?
Yes.
I missed what you said at the beginning.
Just to repeat it.
Sorry.
Just to reproduce the kind of meeting we have today every month or every 2 months, so as to ensure we synchronize ourselves, that we know what everyone is doing, we don't repeating the same scene, and if we have ideas to share, we can share them.
That sounds great. This is a largish group of people, so I'm not sure if collecting all of these people is possible or desirable every month or two, but maybe. How often are Coq Working Group meetings, for example, and is this a reasonable topic for discussion at them?
So I think we haven't recovered the usual schedule since 2020. So we used to have one every
2-3 months.
Isn't it used to be a monthly?
Yes, it used to be a monthly.
Monthly when
So I think we were doing once
when we
remotely.
had 2 sites in France.
But weren't we doing one remotely?
Yes.
And
yes,
then another.
At the end, yeah.
And so like every 2 months we would meet physically, usually in Paris. And the other occurrence was remote.
Yeah.
Well, I'm not sure we will have funding for meeting in presence.
No, we can have remote ones. I mean,
that often actually. And we had this question when preparing for this one, where you said. So.
I think we can get funding. We should ask for it.
Yeah.
There is a consequence of remote meetings.
Well,
very cheap.
maybe very quickly. What should we look at for a next discussion?
The next, you mean the next time?
Yeah.
When now?
What would be a good opportunity to meet in a couple of months with most of these people?
At least from my point of view, which is not an expert in UI, there is a lot of technical discussions that I would like to understand better. For instance, we are talking of LSP at a high level, but we never see the details, which I think are important also.
The paper on
I'm
Flash.
in the same position very much.
Very interesting to me as well.
So I don't know. So for instance, we can organize the next meeting with 1 or 2 technical talks describing what is LSP or at which point of LSP we modify things, or another talk about how to represent graphical notation in textual, how to connect a textual notation with a graphical one, or so that. I think this kind, at least from my point of view, again, this kind of technical things helps to understand where we are going.
I think schedule-wise, probably you're not aware, but there will be a Coq user and developers workshop, probably end of May, June, but that will be physical in Nice. And I guess much before that, just another meeting on UI to have this kind of talks. Maybe.
What
all right.
Another kind of topic that could be addressed as part of a working group is, I think, at least in the Coq LSP and VS-Coq2 projects, there are a few features that interact very closely with Coq. So for example, we talked a bit about having Coq emit more structured output for goals and things like that, or in general, more structured output. And so there, I mean, I don't know if you share the same view, but I think these kind of topics are so close to Coq itself that I think it would make sense to have a dedicated sub-working group inside a Coq working group on this, because it's, of course, I mean, the point is to address the needs of UI developers, but it also probably it will involve modifying Coq a bit.
Yeah, the thing is, this takes a lot of time. So what I found is when I propose such a thing, people usually didn't want to participate because they felt it was taking too much time. This is not a thing. So also you need to keep into the trade-off. It's like the web page of Coq, it's something very important, but who has the time? So yeah, absolutely.
My feeling is if we pick, if that is a Coq working group, so it's not just in user interfaces, it's a working group, and then we pick 1 or 2 very specific topics that we already prepared in advance, and we did a bit of work, then the trade-off might become better.
I think, as you know, I've been very busy with this, but in my experience, I think people have underestimated a bit. Actually, this was that was actually Benjamin many years ago. He told me, "Oh, really? That seems like a lot of things." I proposed he understood this, and he told me, "This seems like a lot of things." And I always remember this phrase actually Benjamin told me. And yeah, like I think we shouldn't underestimate the effort for these two. So yes, I mean, I think in my opinion it's okay, but also people, this working group, I mean, it's not something like, for example, these issues you are talking about, like the structures. Is for example, like it's something we've been serving structured data for a few years. is something that requires a lot of trial and error.
Sure.
So yeah, I'm happy. I mean, I've been doing that for a few years. I really like with some people using the tools, but it takes a lot of time. So yeah, I think that's the solution. But yeah, but many times is the main difficulty I found is people not having the time to discuss, and then they lose more time because they implement their own solution and then they lose way more time. But okay, that's a choice, not mine. But yeah.
Okay, so from the last couple of minutes, here is a proposal. It sounds like trying to merge this discussion about user interfaces with the actual Coq Working Group meetings maybe the timing is not quite right. So I would propose that we pick a, say, 2-hour slot in a month or 6 weeks, and spend a good part of it, maybe half, on a presentation from somebody that knows the internals of, for example, LSP, and can really teach it to everyone that might be interested in using or doing research on it. And then maybe a month after that, another topic like internals of VSCOC2 or something like that. I think if we do a few 2-hour sessions like that, we can exchange a lot of information, and then maybe see where we are in a few months.
Can I suggest that maybe we collect a list of what technical topics people want to hear about, and then every time we meet, some of them get addressed by people who are experts or people who have prepared a presentation. So just so we have the whole pool to pull from when we're thinking of, okay, what maybe can I present at the next one?
Sounds great.
Yeah. That's great. Okay. We will need some kind of forum for organization and discussion. I don't know if that's an email list or one of the Discord subgroups or something. Does somebody have an idea?
We usually use Zulip for this kind of synchronization.
Okay.
Threads.
There's even Coq users.
Yeah, there is a stream.
Interface,
There's a stream on
stream.
user interfaces, yes.
But which is not very much used so far. It will become used.
All right. So to jumpstart the process, I have an email list of all of the people that that I have been sending back and forth with. I think there are some people here that are not on that list. So, you know, if you got my email this morning about where the Zoom link is, you don't need to respond. But everybody else who wants to be included in this discussion initially, could you please drop your email address in the chat?
Mm-hmm.
And then could somebody point me to where the Zulip channel is with the user interfaces? I am not a big Zulip user, I'm afraid, but I can become one. And then we will use the Zulip channel to announce a when to meet or something equivalent for setting up another discussion in about a month, maybe to talk about LSP. Since that seems to be the common intersection of many of these discussions.
So you continue organizing then?
I am happy to continue organizing for the next little bit, and then maybe somebody else wants to take over.
Ok. En fait, tu peux poster le lien, là. Avec toujours pas apparaître? Si, mais j'ai pas. Allez. Allez. J'ai pas essayé le chat. Bah, je pense que le URL ça marche. Donc ça marche. Non, là t'es dans un. Mais ça marche.
Qu'est-ce qui se passe là?
We'll paste the link. Yeah, okay. But you just send the link.
I sent you an email
in the WebEx.
Great, excellent, got it. Okay, very good. Any last thoughts from anybody? For me, this has been super informative, especially just in the sense of understanding who's working on what. I would like to go much deeper into many of the technical topics, but at least we have names and faces and a sense of groupings of people and names of projects. I think that's already going to be very helpful.
Everyone, you can put your slides on the wiki page of the Coq Working Group so that we can gather them.
Great.
Yep.
Excellent.
All
right.
Can you upload files there?
Yeah, I mean, I can, so I guess.
Okay, I filed in the past and try again here.
Just drag and drop.
Yeah. Okay.
You can commit them to the weekly and push.
Maybe I can just quickly mention we might have. We are still discussing dates, but we might have a kickoff meeting for the CoReact project sometime, possibly in late April, and I might just send you an email if people might be interested in that. Also, I think we might host it in hybrid mode so that it's easy to attend. But I mean, we are still planning it, so it would be very nice to have some interaction on this topic. And thanks again for the organization.
Yeah. Thanks, Benjamin.
All right. Those in Paris, I hope you enjoy your dinner.
Thank you.
Everyone else.
Have a good day.
Thank you, and talk to you later. Bye for now.
Bye.
Bye.
UI was one of the next.